Aloha kids, let's take a look at our chapter 5 practice test, which we have right here. We've got our first questions there. Those are theorems you're supposed to know from isosceles triangles. These are things that are frequently known before you come to this class. Let's take a look right here. It is. And you'll see we had these highlighted, at least one of these highlighted here. If two sides of a triangle are congruent, so I'm looking at this right here. Base angles theorem. If two sides of a triangle are congruent, then the angles opposite them are congruent. And then down here, if two angles of a triangle are congruent, then the sides opposite them are congruent. So the first one we got up here, if the sides are congruent, it gives us those congruent angles in there. Let's try a different color here. We can see those matching up there, just the sides opposite. Down here, it's doing just the opposite to that. If the angles are congruent, this is showing those sides are congruent. So remember, geometry often is giving you other information. When we tell you one thing, there's something else we want you to notice, and it's the start of the story, not the end of the story. Okay, let's get rid of all this junk there. Okay, let's go back to our worksheet here. You also can see we were using that on these ones here before too on a previous worksheet. The sides are congruent. Whoops, it gives me congruent angles. These are congruent. These are congruent. That's why they're marked like that. Really important to be marking those angles. Okay. Postulates for proving theorems congruent. Again, you've got all that in those journals. Great idea to put those into your notes. So let's just take a look at that. Right there, you've got the SAS theorem. Okay, we got the SAS theorem right here, side angle side. Included angle it mentions in there, can't miss that. Included angle, got to mention that. You got your diagrams over here. Again, these are great things to be looking at in your studying. We got SAS, so that's one. Proving triangles congruent, this is 5.5. We got a couple more here. They'll come up in just a second. There we are. We got the SSS right there, and we got the HL right there. Read through those for more details on those. And let's get rid of those. And we also have these two right here. ASA, angle, side, angle. Again, sides got to be included. Note that. And AAS, angle, angle, side. That's a non-included side. Important to know included versus non-included. Listen to the definitions we've had. Look at it right here. Connects the vertices of the congruent angles. And practice these. Look at the diagrams. Don't be afraid of making mistakes on your practice. You'll get it figured out there. Oh, what do you know? We got them all right there for you too. 3 and 4 is just matching it up. Remember, get your angle and, don't forget your angle and segment notation. And first letter goes to the first letter. Second letter goes to the second letter. I almost went too far. Third letter goes to the third letter. Match them up. Those are correspondences. And we haven't talked about this one. I talked about it in one of my classes, CPCTC, corresponding parts of congruent triangles are congruent. If two triangles are congruent, all their parts are congruent then. This is in 5.7. But it's something that gets used a lot right after you prove. You can't always prove two parts are congruent straight out. Sometimes you got to get the whole triangles or the whole polygon congruent. And then from there, you know the parts are congruent, but that just happens. On these, this is where you're using, you know, the SSS, SAS, ASA, whoops, AAS, and HL. Remember, there's no SSA or ASS. HL is kind of one of those, but that's a right triangle. You have to have the right triangle, but you don't have that bad word in there. Don't forget to mark your properties. You've got a reflexive here. Does that give me enough to make it congruent? You got to decide. If it's one of these, geez, I got two pairs of sides and an angle, which could it be? Does it match the definition? You got a property on this one. Don't need anything on that one. Property to add here. Property to add here. This one's different. You got reflexive here. This is going to be alternate interior angles. And again, you can see these coming up right there. There's my two lines in a transversal. What are the angles that they're giving you? Hint, hint. You also have these lines parallel with this transversal here. What angles is that trapping to show you are congruent? So you got a property on that one too. These ones, don't forget to put your correspondences in, get them correct. You got to do that. This goes back to the opening problems here. So again, this goes back to the opening problems we had here. If two angles of a triangle are congruent, the sides opposite them are congruent. That's that theorem I showed you from 5.4 earlier. So if the two angles are congruent, the triangles are congruent. Well, you can see these two angles are congruent. They're both 62. So you know these sides have to be congruent. That gives you your equation. You're not going to be using this one. That's a distractor. Two sides are congruent, set them equal. And you can find your x right there with that. Now, to get the y, you're using the triangle angle sum theorem. These three angles of a triangle, what do they add up to? 180, you can get that. And then find the vertex angle above. There's a couple of ways to get that one too. You don't have to find y first. You can use 62, 62 and just figure out what that one is, and you got the answer. Or if you get y, you can plug it back in and find that. Okay, same sort of thing over here. Before you can find D, you got to find C. So you find C, and that's going to be, I'll give you a hint, 58 or 64. But just like you said, what do these three angles have to add up to in a triangle? 180. So take advantage of that. Once you get those, well, if these two angles are congruent, then these sides are equal and you got D. If these two angles are congruent, then these sides are equal, and you don't know much about D then, so probably should have stopped while I was ahead. But find that one in there and you got it. On this one, this is just more kind of like you're doing on that worksheet. I'm telling you, mark your stuff on here. dw equals TP. I should have really had lines above this. That would have been better. Don't know why I didn't. Oh, somebody else made this worksheet up. That's why. So mark it. dw congruent to TP. dt pw. You got a reflexive property you add in here. Again, what theorem did you use to justify this? That's going to be SSS, SAS, ASA, AAS, HL. But don't forget to mark your third part over here. Got to have those three parts shown to do it. Now, 19. Vertex angle, base angles, legs. This can go back to our 5.4 again. Right here, you got all these up here. Legs are your congruent sides. Okay? Vertex angle is included between the two legs. So notice this is all color coordinated. Green here matches up with the green here. Purple matched up with the purple. And so on these. But find those spots, see if you get them. Don't be afraid to make a mistake. You make a mistake, fine. Learn from it. Get better at it. What did you look at that was wrong? Okay, so let's go back. That didn't take me where I wanted to go. Worksheets, tests, practice. So that's where you're going to name these. That's all that stuff from 5.4, just going in there, using it. Name your vertex angle, your base angles. What's my base? Remember, the base is a segment, so that's going to be something like MI. I know that's not in there, but just showing you the format. Legs are segments. Name it with a segment. Angles. Make sure you get the angle name in there. Okay. Proofs. Again, we always start off with the givens. Don't miss that. Then look at it. Geez. Oh, I wrote this out wrong here. This should say segment bisector, not angle bisector. I got to fix that. Hopefully I put it like that on your worksheet. I don't know if I did or not. So again, not sure if I wrote segment or angle bisector on your worksheet. This is written up separately. It should be segment bisector, but that's a hint. So again, read it carefully up here. IC bisects MH. So MH is getting cut in half. This segment is getting cut in half. IC is doing the cutting. What are the two congruent segments I'm going to get out of there? Okay, if this segment is cut in half, what are the two congruent segments you're going to get there? That's what's going in there. So like on this one, angle 3, MTI, that's this angle. Let's get a better color in there. That's this angle. And HTC is this angle. Or you could mark them like this. What kind of angle pair are those? What do we call those angles when we see them? I'm telling you they're congruent right here. So we're going to do that. This one, number 4, triangles are congruent. Triangle MTI, what's the corresponding to MTI? What goes with that? Get it in there. And again, our reason here, that's just going back to our SSS, SAS, ASA, AAS, and that's an HL. In there, pick it out. I gave you the last step there, that's CPCTC. Notice I got the triangles congruent, and then the parts are congruent after that. Corresponding parts are congruent, triangles are congruent. Again, so 21, really quick here. What's over here in the givens? Just read the problem up there. Read the problem up here. Put it in. Always start off with that. Then read what they are. What does it make you think? Perpendicular lines form congruent right angles. Well, geez, GH is the perpendicular bisector of CS. So we got perpendicular and bisector in here. We got a couple of things you got to be paying attention to in there. Well, this is using the perpendicular right here. Perpendicular lines form congruent right angles. What angles are formed by the perpendicular lines? Look at your diagram. Geez. There's our perpendicular. What are the two right angles? Name them. CH is congruent to SH. Geez, that's really pretty much the same. I want to get rid of a couple of things here. That's the same thing we're doing up here. Definition of segment bisector. Take a look at that. We got a segment bisector. A perpendicular bisector is a bisector of a segment. Look at it. Does it make sense? Is the line that's getting bisected named correctly? Give me the parts of it. Okay. Get rid of some of this stuff. And we got a reflexive property here. Good old reflexive property. That one you should be noticing all the times in there. Same spot you've seen it in this other some diagrams. And then why are these triangles congruent? SSS, SAS, ASA, AAS, HL. Still doing a lot of the same stuff. Knock it out, kids. Thanks for trying. Hope this helps. Not giving away answers, trying to help you think, help you see where to find them. If you don't like it, let me know. I can always make the next one different and better. Sorry if this one isn't perfect, but if it helps, let me know. If it doesn't help, let me know. Feedback is important.